Hey, I'm Carroll, and we're going to be doing some extreme physics for you today. My partner Alex on his hot rod bike. We're going to be doing some demonstrations. Alex is going to be doing displacement, I'm going to be doing some friction, and we're going to finish it off with the grand finale right now.
So alright, hey guys, I'm going to show you distance and displacement. Now whenever you're performing these stunts, make sure you wear a helmet, obviously. The first thing I'm going to show you is distance, and I'm just going to bike off down there somewhere. See you later. Alright, so distance is the length of the route from point A to point B. Right here's point A. I'm going to go point B down there, maybe about 50 yards on my bike. Let's go. Yeah, this is distance. I'm going a certain length. There's a car coming! So I've reached point B now, and that's probably about a distance of 50 yards that I've gone. So I've gone from point A to point B in a straight line with a distance of 50 yards. But distance also counts in if you go in a circle or if you're going around in a lap. So I'm going to show you what I mean. I'm going to go around in a circle right now. If I can get this thing going. So distance is the amount of yardage I actually travel. So I would be going, each time I go around the circle, it'd be the what's it called? Circumference of the circle. That would be the distance. But once I get back to where I just was, where I started, right here, my displacement is actually 0. Because displacement is the, what's displacement? I don't know how to explain it. Alright, so I remembered what displacement was. I'm sorry about that. Displacement is the distance as the crow flies from where you started to where you end up. So if you're talking like a right triangle or something and I go this way and then I go 90 degrees another distance, the actual displacement would be from where I started to where I end up as the crow flies. So like I just did in a circle, my point A is the same as my point B, so my displacement is now 0. I'm going to show you to the extreme. I'm going to bike around the whole world and I'm going to be, we're going to find out that my displacement is 0. It's going to be kind of upsetting because really I went, I don't know how far. But see you later. So, I just went all the way around the world, and I'm back where I started. My displacement's 0, but my distance is however far the circumference of the world is. But if I didn't know what the difference between distance and displacement, and I came back after my super long world record journey, and they told me my displacement was actually 0, I'd be kind of upset. So just remember, displacement is the distance as the crow flies from point A to point B, and distance is the length of the whole path that you traveled. See you in the next stunt.
Alright, so today we're going to be talking about friction regarding my skateboard. And so the equation for the friction force is the mass of the object times gravity times the coefficient of friction. And I'm going to do a bunch of examples on the rail over there doing different grinds in different positions. And in each example, my mass is going to be the same. The force of gravity is going to be the same. So it depends on the grind and the coefficient of friction between either the bottom of the board and the truck, or the bottom of the board and the rail, or the truck and the rail, which will decide how fast I'll grind. And remember, don't try any of these things.
It's good to go.
So the first grind I'm going to be doing is a front board, where this part of the board will be sliding on this part of the rail right here, like so. And the coefficient of friction between the board and the rail is pretty low. And since the equation for kinetic friction is the mass of the object times gravity times the coefficient of friction, there'll be little friction due to the low coefficient, and I'll slide really fast, making it pretty easy to slip out and break my face. So here we go. So the next trick I'm going to be doing is called the feeble grind, where the board grinds on the rail like this. And although the same part of the board with the low coefficient of friction is still sliding, Also, the truck or the axle is grinding. Makes a lot more friction as I'm grinding. Makes it a lot easier to fall forward and bust my lip. So, here we go.
Is that worthy?
Alright, so just remember from before, the equation for friction is the mass times the gravity times the coefficient of friction. In the second example, I had a higher coefficient of friction, so there was more friction as I grinded through than in the first example. So today we're going to be doing some diving examples. So the first dive I'm going to be doing is off the 3-meter board here. And when I first jump upwards, the board's going to transfer energy to me, which I'm going to use as kinetic energy to propel me upwards. Then when I hit the maximum part of my height, I'll have the maximum potential energy, and all the kinetic will be converted to potential. Since the potential is equal to the mass times the gravity times the height of how high up I am from the water, I'll have my maximum height, so maximum potential energy, and then that'll all be converted to kinetic energy. So I go downward toward the water, and then I'll have my max kinetic energy right before I hit. So here we go. Alright, so in this next example, I'm going to be doing the same thing off a lower board. So the same principles of energy will apply. Except I'm going to add a little surprise ending to demonstrate some Newton's laws. So here we go.
Evan, you do that, I want to see your hands over your head.
So that last example, when I hit the water with all my force downward, it hit me with an equal and opposite force back, which didn't feel too good, but it's all in the name of science, so there you have it.
I wasn't. Okay, I wasn't. Okay, I wasn't.